Okay, so today we begin with rectilinear motion with variable acceleration. So far you have dealt with rectilinear motion when the acceleration was uniform. Now we see how to study the rectilinear motion of particles when the acceleration is varying. So sometimes a particle moves along a straight line with accelerations which varies with respect to either x or v or t. So we'll consider the cases of acceleration varying with respect to x, with respect to v, or with respect to t. The first case, whenever the acceleration of a particle is given to you in terms of t, as a function of t. So when acceleration is a function of time, you know that a is dv by dt, which I can write it as f of t. So dv becomes equal to ft dt. Integrating it on both sides, velocity from v0 to v and time from 0 to t, we get velocity in terms of t. So we get the velocity in terms of t, a equation in terms of t. So what I mean to say is, when an acceleration is given in terms of t, you integrate that equation to get velocity in terms of t. Then further, v is nothing but dx by dt. So instead of v, I'll write dx by dt is equal to f of t. Once again integrating dx from x0 to x and ft from 0 to t. This will give us x in terms of t. So if I have an equation in terms of t, acceleration in terms of t, if I integrate it once, I get velocity in terms of t. If I integrate it further, I get x in terms of t. Now, if I have a which is given in terms of x, so if I have a which is given to me as an equation in terms of x, then acceleration can be written as v into dv by dx, which will be equal to f of x. So v dv is equal to f of x dx. Integrating on both the sides, this will help us to get velocity in terms of x. Acceleration as a function of time. So if acceleration is given as an equation in v, then acceleration is nothing but dv by dt f of v. So dt can be written as 1 by fv dv. So I can get equation for t in terms of v. Again, dv by dt can be written as dv by dx into dx by dt. dx by dt is nothing but v, which I can equate to f of v. So v dv by dx is equal to f of v, or dx